it's the Twitter stuff. Fix it immediately. You didn't put the ACHECs there, so you didn't put any ACHEC or... So is it Kabelac or Kabelac?
Kabelac, but I am using without the any
Kabelac.
extra parents or apostles or whatever. It's easier for other people.
Yeah, but not to read if you are not Czech.
Well, Kabi is mine.
Kabi. 2 minutes. Oh, wow. Quite full. Are you ready for that? Okay. Are you ready for that? Kabelac.
Kabelac.
Oh, so it's Kabelac. Okay.
There's another car on over the E. Yeah, thanks.
Okay, so we're ready for the last talk of this room and also for the DevConf. Zdenek Kabelac is going to talk about lvm2 cache.
Okay, hello everyone. Hope you can hear me. So I'm Zdenek Kabelac. My presentation today is going to be LVM oriented and about the cache, but not only about the cache. And for those who don't know me and are not part of a company, I'm often available on the Freenode, LVM channels and DM channels as a Kabi, as underlined as my nick. So who expected that I will be blending something like Tom Dixon does? It's not going to be this kind of presentation, but we will say a few words about the LVM updates. I will remind you how the team provisioning works. Then we will focus on the cache support. I will mention a few words about the new tools you have to install on your machine. You probably already have it, but if you don't, you will need them. Some words about the problems, how to tune your system to perform better, and if there is enough time, what we are going to do in the next year. So what is going to be broken next year. So updates. I'm not sure how often you watch how many daemons are running on your system, but from the Fedora 21 and RHEL 7, we have a new daemon, lvm2. It accelerates the access to metadata. It's caching them, so basically it's a cache for metadata. It's more advanced than what UDEF does, so this is what you are now using, probably, if you are using these distributions. On the other hand, if you are using the older one and you have the new release, you will have to manually enable it if you want to use it. So look out your lvm-conf file and check the settings, and you can enjoy the cache if you want to. Other quite interesting thing for user is the select support. It's going to be improved, but already you can use it. It's the -s, capital S letter, or -select. And instead of doing some fancy Python parallel bash scripting, you can directly select features you want to see and select what you want to contain them, and just run what you need to. So you don't have to like LVS everything and then parse the stuff and then grab through that stuff. And directly this is embedded into LVM, and the newer versions or later versions will also support the creation. So you can like create a snapshot from a device which has this characteristic. That's what is going to be the next thing. We often add a new fields or new columns, and this applies only to new segment types. So they are often empty, and the number of columns gets wider and wider, and your terminal has a limited size. So we added a new feature to compact output. So reporting now is configurable in a way that the columns which are empty are discarded. So basically, if you want to have switch this option on, and your byte of output will be compressed. We have here Heinz. So he is the master behind the RAID thing support. So now we have the RAID 1, 4, 5, 6, 10 supported, and sharing the same code base as the MD-ADM is using. Couple of new features has been added. Scrubbing is one of them. So we are still not feature pair with the MD-MDA, but we are getting close to. So you don't have to use extra MD-ADM. You can use the built-in LVM ADM MD support. Docker team is thinking that LVM is too heavy, or was too heavy for their support. So they basically rewrote everything we did, but they considered maybe usage of the thin pool is something that they can try to use. So we now support the external usage of thin pool. So if you don't want to use thin volumes, you just want to use thin pool, and you want to manage your volumes yourself, we support that. For thin pool, we also report the health status. So now you can read if the pool is getting out of data space, out of the metadata space, or it completely failed. And I would like to point out two new man pages. It's the LVM thin man page and LVM cache man page. Probably more welcome. It's our new idea how to explain in better details how to use features like thin provisioning, caching. So if you don't know how to use it, check these man pages. I think we try to put a lot of knowledge into these pages. So how the thin provisioning is usable. How many of you have you tried? Not many. Anyway, so I think it will be useful to remind it how it works. The first line is the easiest one. You just create a pool which has 1 gigabyte, and it will be thin pool. We spent a lot of time last year to improve the command line options to support type command line more precisely. So now you can explicitly specify what are you creating, because the -t option is kind of smart one. So it tries to deduce what you want to do. And if you prefer explicit specifications, so then use the type one. So the second one could be easier to understand for some of you. Then we have the conversions. And, well, thin provisioning is a completely large topic, so I just want to remind how it looks like with the thin provisioning, so you can compare it with how the caching, how we added the support for caching. So instead of learning something new, we went with existing pool stuff and mapped the things for the caching. The first line, the H and 1 gig thing, is not yet supported. It's kind of harder one. So you still need to go in smaller steps. You have to first create the cache pool, and then you say which volume you want to cache. So basically, the first type cache pool creation creates the 1 gig cache pool. You can specify with the following arguments where the cache pool is located. I would suggest the SSD drives or something like that. It's not usually. So far, LVM is not smart enough to detect which of your PVs in the VG are the fast one. So you have to somehow instruct where do you want to put the cache pool. And the second line with the type cache is the conversion one. So the last my LV is your existing linear LV, for example. So you specify that you want to convert this LV to cached one. So you specify the cache pool, and you specify the name of the LV, and voila, it's done. If you want to uncache, again, we have the uncache option for LV convert. And if you want to preserve the cache pool, which means that you split your existing volume and your cache pool, and you can reuse the cache pool for something else, then it's the split command. So the split cache will just dismount these things from being together. As you can see the picture, there is the cached LV, which basically references 3 objects. It's the origin LV, the cache data LV, and cache metadata LV. And the cache metadata and cache data LV is the cache pool. Unlike with the thin provisioning, the cache pool without the origin is basically useless. So it's not something you can activate, but it makes sense to reuse it. So you can like flip from one cached volume to another cached volume. If you are short on space for caching and you have a lot of volumes and only few of them are needed to be activated at one time, it makes sense to use it this way. So what options we have for settings? Of course, you first have to select the mode. Cache mode is the important thing. Write-through is the safest one, because whatever you write, it always hits also the origin. And if you want to play with the cache, I would suggest to start with this mode. It's something that you cannot destroy anything mostly. So the important notification is that you have to decide it during the creation mode. Go on.
Are you planning to support this write-around thing that the Bcache has?
So the question is if we will support more cache modes, like I don't know what Bcache is doing, but well, write the Bugzilla and we will see. I haven't never heard about that, so we just support two modes: write through and write back. And you have to select this during the creation. You cannot currently, we do not yet support the change in runtime. And then we have the policies. I think Heinz and Joe started with the idea of having many of them, but at the end they somehow compressed them into one smarter one with a lot of parameters. So,
Can I add something to that?
yeah.
The idea again is to be very flexible and open to future enhancements. So this is plug-in logic.
Yeah, basically.
Cache replacement policy. So in essence, the algorithms selecting any certain cache block for demotion or promotion, right? Oh. Did anyone not hear that? Give me a hand. For the recording, sorry. So what I just said is that the idea on the design side of things is flexibility. So we have plugins in the kernel which plug into the device mapper caching target, which essentially have the core functionality to decide on cache promotions and demotions based on, you know, fancy algorithms, etc. And the MQ, the multi-queue cache replacement policy, is a little bit smarter because it's basically suitable to many different loads coming basically down the stack into the cache, and it adjusts dynamically. But that doesn't mean that we can't enhance it, which we actually did. There is some research going on internally, and probably next year we'll see some enhancement to even that already very flexible MQ policy. Thanks.
Yeah. It's worth mentioning that if you want to write your own policy, LVM is designed in a way that we will support also the external type of policies. So it's designed to support even other than non-LVM DM policies. So basically we have two of them. One you can select. So far the cache policy MQ. The cleaner one is when you detaching the policy, you have to flush everything back to your origin. So it's either an internal one. And then we have the settings for the multi-queue policy. I'm not going into the details. I think the kernel documentation is, well, it's not optimal, but it's going to be improved. But there you can read more information about which field does what. Just the generic idea is that if you are starting with the cache, it could be a wise idea to lower the values for getting cache more quickly filled, and then you can restore the values which have been found as optimal for long run. So, for example, if you want to have quickly filled the cache, lower the sequential threshold, so the less writes will cause movement to the cache. So one thing is to set up things, and other thing is to check how it works. We support now a lot of statistics about the caching, so you can check out the status, and probably we will provide soon some profiles. So a single profile option will give you a whole cache status with all these options, because as you can see, it's a lot of texts to write, so it makes sense to use some kind of macro for that. And what you can use with the cache? Of course, linears and stripes are simple, but you can mix them also with the RAID and mirrors. And for thin provisioning, so far we support the caching of data volumes. We expect that the metadata is already on the fast spindle, so it doesn't make sense to cache it. But for data volumes, it's usually the slower drive, bigger drive, and that makes sense to cache the most used data. We probably will support even individual thin volumes, but we are not yet there. So basically these types are what we currently support. And of course it makes device stack a bit more complex. So if you can imagine, we have the thin volume, then we have a thin pool. Under the thin pool is the cache, and cache again could be caching the RAID volume. So it's getting complicated with every more and more things. So I mentioned that we have some tools you need to also install in your machine. In Fedora and RHEL, it's device mapper persistent data package. In other distributions, something different, but you need to have the thin check, thin dump, thin repair, thin restore for thin work, and the similar tools now exist for the caching. And there are other tools to detect the cache size and metadata size. LVM usually tries to do something smart here, so you do not usually have to run this yourself, but you can, and you can build your cache pool from single volume up to whole pool. Now I'd like to mention a few things I'm noticing when I do some kind of support on Freenode. And it's often that users are mixing PVs between hosts and guests. It's, let's say, evergreen topic that the host is manipulating with the guest images. So you have to really set up your filters so you are not allowing different machines to work with the same metadata without any locking. It's critically important because otherwise you may easily lose your, not lose, but you will get into troubles because you will corrupt the metadata if you try to write from multiple things to the same place without keeping the logs. With the lvm2, we introduced a new type of filter. It's a global filter, so it's getting a little bit more complex than it used to be. So in the past, filter was enough. With the lvm2, we have also the global filter, which is like, filter is now like sub-filter for global filter. And I always suggest to use the whitelisting. So if you don't need to allow to scan the whole system and you only know few devices you want to use, set these as accepted and reject everything else. It will speed up the LVM scan dramatically. I often found the cases where users have thousands of drives because on default, you normally see every created LV as a new possible PV. So we scan everything. And if you create 1,000 LVs, then every command has to check these devices. Yeah, for thin provisioning, it's generally true for every other solution out there. If you run out of space in the provisioning with the provisioning system, you are getting into the troubles. So make sure you are not over-provisioning. We are trying to solve the problems related to this, but it's still not perfect. So you may lose some of your data if you don't react quick enough. So by default, at this moment, we have not yet enabled automatic resize. So make sure you configure your lvm2 to do that for you, and make sure you have the space for automatic resize. Of course, if you will allocate your whole VG for the pool, there is no way how to resize it. So think twice. We will probably add more warnings over the time. So if the user is unskilled and is not reading the man pages, we will try to put some warn signs to avoid some data losses. Yeah, the LV extend hint, if you are running into out of space problem, you get into the blocked mode. So basically, LVM will try, if you have the filter set up to scan also the thin volumes, the LVM may deadlock on scanning itself because it will try to read already blocked pool. So there is some hint how to avoid it. Some performance tricks. I have seen a setup where the user was using like, I don't know, 100 cores, CPU cores, and he was pushing a lot of parallel jobs running on a single pool. Of course, this is not a good idea. At this moment, after discussion with the main authors of the target, I would not go above like 16 parallel jobs pushing to the single pool. So think twice and use more pools. It's not always necessary to use a single pool. Make sure you have your data volume and metadata volume on the PVs you want to have them. So the metadata volume should be always on the fast spindle. Also, the chunk size is something to think about. If you do not need a lot of snapshots, the bigger chunk size, of course, means a better performance. And zeroing is, again, something to think about. If you don't need extra security, and you may like leak some data from the pool and use the bigger chunk sizes, I would suggest to avoid the zeroing. Usually the file system takes care and will not allow you to use uninitialized data, so zeroing is a good option to check if you need it. If you have 64K blocks, it doesn't matter, but if you have 1 meg chunk size, zeroing is something you do not want to use because the provisioning of a new block means 1 meg has to be zeroed on the first use, so it takes time. As always, use the latest and greatest kernels and latest tools because especially in the thin provisioning, recent 2 kernel versions made a great improvement in performance, especially from the Docker team. A lot of, I think, hints came in, so a lot of things have been improved. So, what do we plan to do? Clustering is a topic which has a lot of users, possibly, but the complications with using DLM is it's not simple to configure a cluster. So we work hard for already a few years on a new locking manager, which should support the sunlock thing. So you may expect that you will be able to use the clustering without the DLM stuff, only with the sunlock. We are not yet sure when it will happen and how fast it will happen, but you may expect that this kind of solution will be brought in during either this year or something like that. As I said, MD-ADM, we want to be feature pair with this, so a lot of new support for MD-ADM will come in, mainly the conversions between RAID types, so you may expect this type of improvements. I think, yeah.
Thanks. So as it reads there, the idea is further down the road, and we are still slicing the sequence of added features up when things go upstream and land in RHEL and so on. But the idea is, as you probably know, otherwise I'll explain it for a bit, we can create all these MD personality-based mappings through LVM as we speak, but RAID 0. Before we got to this thought to enhance it, to support things like RAID level conversions, which is all known under the term reshaping in the MD-ADM notion. We didn't need RAID 0 because we have a striped target, a device mapper native striped target. If we support it, we need RAID 0, so I added RAID 0. So we will be able to do the level switching. You start out, say, with a RAID 5, and you noticed I need this additional resilience, switch the level to RAID 6. MD-ADM can do that, obviously. We can't so far, so this is an example for feature parity. MD is able to change the layout. If for some obscure reason, say a RAID 5 left symmetric algorithm layout scheme is not performing best for you, and you want to try out the others, you can do that in the future and switch to, say, RAID asymmetric, if that helps. You will basically evaluate that. And other thing is we can't shrink RAID 4, 5, or 6 logical volumes right now, neither in upstream nor in RHEL. So the shrinking support will be available, which is rarely used, but if you planned wrong or if there was just a pure admin mistake or something, it's urgently needed by that time. It's rarely used, but it's mandatory. So that kind of thing related to feature parity. Thanks.
Okay, for thin volumes, it's often hard decision to pick the right chunk size, because the smaller the chunk size is, the better the snapshot will be, because the small thing needs to be shared. The bigger the chunk size is, the better the performance is, but of course you have much more space used in your snapshot if you just use a half gig or half meg chunk size. Every change will basically means to allocate another chunk in this size. So we will support a pre-allocation size per thin volume. So basically you will be able to allocate like in half meg chunk sizes, but use the 64K chunk for the snapshot at the same time. So we think it will be a victory for a user. Caching needs more and more enhancements. We will support more types. We will try to support thin volumes per thin volume, since it seems it makes sense to allow also this type. So not only the cache pool data, but also individual thin volumes. Yeah, I'm getting too close to the end. So dbus support. We have seen already a lot of presentation this year that the dbus is getting more and more important. We already have some, let's say, demo support for dbus. We will have to probably switch and orient more towards this support, because it seems that everyone wants to use the dbus. Even Lennart is on the bus, so this is something we will spend a lot of time on that. And what I have not mentioned here, it's been the Bryn's work that he, or let's say Mikuláš's patch. We are able now to do a big analysis of your hotspots on your drive. So basically, we will be able to provide you with a lot of informations about which part of your drive is mostly used. So what are your hotspots and what you should tune for. So, but this is a work in progress, and again, it's hard to estimate any deadlines. So I just would like to point out that the more and more complex device stacks we are making, it's getting more and more complex to support every case. So if you find any bug, don't hesitate and open the Bugzilla and provide the traces. As with thin volumes, also with the caching, it's getting somewhat more complex to support the VG-CFG restore, because your data are now not only inside the LVM as a metadata, but you have also metadata in other types of volumes, which we do not have the control about that. So it used to be easy to go one step back if you make a wrong command, but now it's not so easy, so think twice and don't expect we will do miracles. So if you will just trim your SSD, don't expect we will bring the data back. So I think I'm getting to the end. Here are the main links. You can provide some feedback to this talk, and we are getting to questions. So go on.
One related to trim, since you mentioned it, it's still true that when you're using thin LVs, you have to run fstrim on them to get the space back to cool. And if so, are you planning to support it somehow internally in LVM so that I don't have to have this cron job to run fstrim every day?
Yeah. The question is how the user should run, or if the user should run fstrim if he removes the thin, or
to get back the space from the.
Oh yeah, sure. The thing about the space in thin pool is that if you are using the file system on a thin volume, you have to select how you will, or what you will do when you release the space. There are two options. One is to set up the file system to send the trim with every delete operation. But in general, I would not advise it because it's usually slow. It's not well performing on many devices. So we advise to basically run a cron job every day, run a fstrim application, so it will go through the file system and it will discard in large chunks, 3 blocks, and this works the best. So the answer is that yes, if you have SSDs, if you have thin volumes, use fstrim. And you don't need to run fstrim when you remove the thin volume, because obviously when the mapping is lost, it's automatically deleted. So if that's the question. Okay. Yeah.
I have actually two questions that are possibly linked to each other, maybe directed at you. What was the motivation to integrate the RAID functionality directly into the LVM layer? Why not rely on the storage drivers that are providing this functionality? And second question, that's related to it, is since you now have at least chunks of the MD code directly in LVM.
It's not in LVM code.
No? Okay. You possibly how do you distinguish the functions, function names that are pertaining to the MD functionality for us to distinguish from the MD driver, or how do I know that which comes from which part, which module? This is important for our analysis.
I would direct this to Heinz.
Sure. We are not approaching this from the point of view to replace the MD-ADM notion, understanding of software RAID in Linux altogether. I think we'll see this whole disk utilization to make up component drives of a software RAID long term, because not everybody in the world will use LVM to set up a RAID configuration. Think about the, say, for one storage appliance OEMs, these Synologies, Tecos, you name it. Those all use MD in their product offerings and layer, for example, LVM mappings on top and provide logical volumes being exported to clients. So that ain't going away. This is all about offering the flexibility to have a software RAID integrated in the LVM stack, if you want so. So you can decide, of course there is a downside to that, you can decide to have non-resilient mappings for like temporary storage. You can lose at some feed or something, you can lose and reproduce in short term or something, together with resilient mappings such as for your say thin provisioned logical volumes. You don't want to have the data neither the metadata non-resilient. You might as well say, well, go away with that. I'll put MD on the lowest level. I want to keep it simple. My, say, 3 drives making up a RAID 5 array, and put anything on top what I want, including LVM, right? And do thin provisioning that way. So it's giving you that kind of flexibility, essentially. It's an additional offering to be able to better use resources, if you want so, right? Not the whole thing being redundant, losing, say, a third of your capacity or a half of your capacity or something, but use it for the appropriate logical volumes you need it. So take it that way. I need to remember the other part of that was the split, basically. What's the design in terms of leveraging MD code? The clear distinction is we don't leverage any user space code. The whole user space code leveraging happens in terms of LVM feature additions and code adding to the internal LVM library, exposing that maybe via, you mentioned dbus, for example. That feature set that functionality via dbus. So we don't duplicate any MD user space code or interface into it, but we do have the MD kernel runtime, which has basically a core and another plug-in model, namely the properties, you know, like the RAID 4, 5, etc. properties. So there is a very tiny API enhancement in there to be able to interface into the MDM kernel code to switch levels or to change layout, etc. And there is a device mapper target. So as you know, or like you know, the linear target, stripe target, what you name it, there is a RAID target. And that kernel internally hooks into this edit API, which is very, very tiny. So that's basically the split there, which allows us to utilize that already, you know, field-proofed code, which is, of course, 100% bug-free, right? Thanks. Did that answer your questions?
Yeah.
Oh, cool.
I think I should comment from the LVM side. LVM has some unique features which no other subsystem has. So in some cases, if you are swapping or PV moving devices, it's something that MD RAID cannot do. So we have features which we cannot support any other way than except from the DM devices. So we can, for example, wrap the B cache as a DM device as well, probably, and support this type of cache through the LVM. But without this DM thin wrapper, we cannot basically use other targets easily because they just are not compatible in terms of feature set. So for a lot of operations, we need a lot of features. And if the original device target does not support them, we have to wrap them and support them through the wrapper. And then we can use them through the LVM. Okay, so if anyone else has some more questions, we can probably solve them outside. So thank you for your attention, and see you next year.
So this was the last presentation of this batch of presentation for the DevConf. So we hope you enjoyed it, and remember to give the feedback for the presentation you attended, and have a nice day.